Our universe is four-dimensional, consisting of 3 dimensions of space and 1 of time. When we combine these, we get a fascinating concept known as space-time. While you can't use it to bake a pie, space-time has a unique property. It can bend and stretch. Now let's dive into something even more exciting. Space-time can warp in such a way that waves traveling through it can move faster than light. When it comes to propulsion or moving through space, using hot gas ejected from the back of a spacecraft isn't the most efficient method. A more elegant approach would be manipulating the fabric of space-time around the ship, which brings us to the idea of the Alcubierre warp drive. Though still a hypothetical concept, the Alcubierre warp drive might one day allow us to travel across vast distances in space. It works by contracting space-time in front of the spacecraft and expanding it behind, enabling the ship to travel from one point to another incredibly fast. Outside the spacecraft, observers would see it moving faster than light. But inside, you wouldn't feel any acceleration at all. If we could make a warp drive a reality, it could revolutionize space travel, making it possible to reach distant parts of our solar system and even neighboring star systems. However, there's a significant problem with the warp drive. It requires negative energy, which involves exotic particles that are still completely theoretical. These particles, which behave in strange ways, are not something we've observed in our universe. While we can describe them mathematically, they are not yet proven to exist. On a positive note, recent research has led to the idea of a positive energy system that could overcome some of the issues related to negative energy. This new system could potentially pave the way for interstellar travel. It works differently from the negative energy model, by using positive energy to create a spherical bubble around the spacecraft. This bubble, made from super-dense matter, would use gravity to propel the spacecraft forward. The passengers inside would feel no acceleration, and time would pass normally for them, all while the bubble distorts space-time around it. Building a warp bubble would require enormous amounts of matter and energy to keep the passengers safe and maintain the correct flow of time. Even if we can't yet make a working warp drive, the idea remains fascinating. If we could reach even half the speed of light, it would only take about 9 years to get to Alpha Centauri. In comparison, Voyager 1, traveling at 38,000 miles per hour, would take over 75,000 years to make the same journey. However, the closer you get to the speed of light, the stranger things become. The mass of an object increases, making it harder to keep moving without infinite energy. Some scientists compare the current stage of warp drive technology to the early days of automobiles in the late 19th century. Back then, cars were possible, but difficult for most people to operate. In the future, warp drive technology could transform space travel, but it's still in its infancy. There's an even wilder theory. Instead of bending space-time, what if we could rip it? In the case of black holes, gravity is so intense that space-time is compressed to a singularity, a point where time itself stops. This singularity might actually be a rip in space-time. If we could survive the intense gravity of a black hole, we might emerge on the other side of the universe through a white hole. Then there's the concept of quantum tunneling. In the quantum realm, particles can tunnel through barriers, bypassing the need for enough energy to overcome them. What if particles could use this effect to tunnel through wormholes, taking shortcuts through space-time, and potentially allowing for instant travel across the universe? While these ideas sound like science fiction, they represent some of the most innovative concepts in theoretical physics. Although we're far from achieving such technologies, the possibilities they suggest could one day change how we understand space and travel through it. If this topic piqued your curiosity, feel free to like the video and share it with your friends. Subscribe the channel and follow for more.